All right, 3.13, trig and polar coordinates. Here we go.
If we wanted to travel from one location to another location, there are several different methods we could use to travel. Walking, biking, driving, flying, boating, etc. Each method has its own advantages and disadvantages depending on the particular situation. Additionally, each method has specific constraints and restrictions. If we were driving from one location to another, we would have to stay on the roads, which are generally formed by a rectangular grid system. If we were flying, we would be able to fly in a direct path to our destination, provided there was an airport. Plotting points in space and defining functions is not much different than the transportation examples above. There are several ways to define points and function in space, each with their advantages and disadvantages. Up until this point, the system you've learned has been the rectangular coordinate system. This system uses an x-axis and a y-axis, and the points are described using an ordered pair x and y. The rectangular coordinate system, also called the Cartesian plane, is very similar to a road grid where we have to go over and then up to define a point in space.
All right, so all of your life, you've basically been with coordinate axes. All right, you've been with a rectangular coordinate axis, which is called a Cartesian plane. And so you've gone out an x and then up a y, or out an x and down a y. And so that's what you've been dealing with the entire time. And so now we get a new system. Okay, this is not the only other system, but this is an other system. All right, so here we go.
An alternate way to describe a point in space is the polar coordinate system. With polar coordinates, we do not use x and y values to define points. The polar coordinate system is much like flying an airplane. To define a point, we only need to state the angle of the point and standard position and sign distance of the point from the origin. In other words, we simply rotate until we are facing the point and then draw a line directly to the point from the origin. The polar coordinate system can be very useful, especially when working with circles, trig functions, and conics.
Conics. All right, beautiful. And so if we have to do a polar coordinate system, a polar coordinate is in the form of r comma theta. And so before in your rectangular coordinate system, you dealt with x comma y. Now, this is a little bit reversed of what you did before. So normally your input values are your x and your output values are your y, yes? Like usually. All right, it doesn't always have to be that way. But this is kind of backwards. And so in a polar coordinate, you're actually kind of doing theta first and then your r. And so it's kind of backwards in my opinion, but I didn't come up with them. Now, you technically are calling them polar coordinates, but I like to call them, so like an xy we call like ordered pairs, you know? This is not common practice. However, I like to call them polar pairs because I think it's funny. All right, so these are polar pairs, but you're really polar coordinates. All right, and so anyway, it is not polar bears, but I will probably put a polar bear on your test because I find it funny. All right, so here we go. However, what's really cool, oh, we need to read this with angst. Ethan's going to read this for us. Here we go. One really cool.
One really cool result of using polar coordinates is that the same point can be represented many different ways.
All right, love it. All right, so we can use lots of different ways to get to Tampa here. All right, so let's look at example 1. So we're going to plot these polar pairs. And so this one we have is 2 comma pi over 3. And so what we need to do is we need to go to pi over 3. And so that angle is right here, yes? But then my radius, my r, is going out 2. And so that polar pair coordinate is right there. All right, and let's do it again. And so now we're going to have 1 comma 3 pi over 2. So again, we're going to go to 3 pi over 2, which is which way? Down. It's going down. And so now it's going down how much? 1. And so let's do it again. And so this one we have 3 comma 4 pi over 3. So the first thing we need to do is find 4 pi over 3. Well, where is 4 pi over 3? What quadrant am I in? I'm in the third quadrant. So 4 pi over 3 is here, but now I need to go out 3. And so that one will be right there. All right, let's do another one. And so now I have 2 comma negative pi over 6. Well, negative pi over 6 is not on my unit circle, so what should I actually think of? Okay, it flips, so where does it go? 11 pi over 6. And so then I go out how much? 2. And so now we are right there. Now, if you saw this, this is actually a pi over 12, and this is technically a 5 pi over 12, and we don't usually use those. You might get those in Calc 3 in college, but we don't use them right now. All right, sound good? All right, cool. All right, let's look at these other ones. And so now we have 2 comma pi over 4. And so where do I need to go first? At pi over 4. And so then I go out how much? 2. So I'm right here. And then this next one I have 2 comma negative 7 pi over 4. Well, where is negative 7 pi over 4? That's the same thing as pi over 4, isn't it? And so now I go out how much? 2. Well, what do we notice? It's the same one. All right, let's do it again. And so now we have 2 comma 9 pi over 4. Well, 9 pi over 4 is not on my unit circle normally. And so what do we need to do? We need to subtract 2 pi. And so how should I think of 2 pi? 8 pi over 4. So I subtract from 9 pi over 4. I need to subtract 8 pi over 4 from it. So I get to what again? Pi over 4. And then I go out how much? 2. And so now it's the same point. Oh my goodness, this is crazy. All right. I wonder where this is going to go. And so now I have negative 2 for my radius, and my angle measure is 5 pi over 4. Well, where is 5 pi over 4? It's in the what quadrant? The third quadrant. So 5 pi over 4 is here. However, what's wrong with my radius now? It's negative. So instead of going forward like this, now guess what? We go backward. And so again, I end up at the same point. I want to do another one with you with a negative angle. Actually, I'm going to do 2 negatives. And so let's go part E now. And so I'm going to say this is like negative 3 comma negative pi over 4. Why not? All right, so negative 3 comma negative pi over 4. Well, where is negative pi over 4 at? It's at 7 pi over 4, so it's right here, yay? However, this would be a positive radius, but I now have a what? A negative radius. So now I'm going backward. And so now I'm kind of right there. What is that the same thing as? Like, what if I went to that in one shot instead of having to go backwards and such? That's the same thing as what? At 3 pi over 4, how far out would it have gone? At 3. And so these things are coterminal. They go to the same spot. And that's why there's many ways to Tampa on that. So now we have negative 2 comma negative pi over 2. So where is negative pi over 2 at? At 3 pi over 2. But instead, now I go backwards. And so now I'm actually right here. And so what is that synonymous with? 2 comma pi over 2. All right. And so those are the samesies. All right, let's move it. And so now we're going to find out different ones. So now I have 3 comma 5 pi over 6. So let's graph it first. All right, so now we have 3 comma 5 pi over 6. And so now, where is that? Where's 5 pi over 6 at? In the second quadrant, and then it goes out 3. And so I'm right here. Now, let's come up with 2 different ones, or 3 different ones. How else can I get to that point? Okay, so negative 11 pi over 6 is our angle. And then what? Okay, negative 11 pi over 6 would not actually work at all. Okay, because negative 11 pi over 6 is actually at pi over 6. All right, so that's not going to work. Now, could we say it's 11 pi over 6? Yes, so that's right here. But then what would be my radius? Negative 3. And so that could work. All right, what's another way that we could work this one? Okay, negative pi over 6, and what? Negative 3, all right? And then what else could work? I'm going to use a positive 3 this time, but let's go backwards. So now what would we use? Negative 7 pi over 6, exactly. So all 4 of those things go to the same point, all right? And there's actually more than that. You could add a 2 pi onto something or do anything like that. All right, so now let's talk about our conversions, okay? So in our XY system, you go out an X and you go up a Y, yes? Know what we've been used to. And so then in our angles, we go at an angle and out an R, all right, out a radius, all right? And so if I were to combine them, it forms this triangle. And everything I'm going to be talking about from here on out revolves around this triangle. So when I teach Calc BC with polars, they just kind of realize this triangle and they can get the four things that we're going to be talking about, all right? So that's kind of how I want to go about this one too. And so when I have this triangle, this is my what side? Who's my princess again? What was her name? Sokato. Cool. And so this is my what side? The adjacent. This is my what? Hypotenuse. So what trig function does that? Cosine. So cosine theta is equal to my x over r. Well, how would I solve for x? I multiply everything by what? R. So x is equal to what? R cosine. See how that worked? Okay, and it's actually derived from this little triangle. So this is my what side? Opposite. This is my what side? My hypotenuse. And so that deals with what? Sine. So sine theta is equal to y over r. And so if I multiply by r to solve for y, what does y equal? R sine theta. All right, so y is equal to r sine theta. You need to know those two, all right? I want to keep going down here. So what kind of triangle was formed here? A right triangle. So what little theorem is used with a right triangle? Pythag. And so I'd have my sides squared, which are my x's and y's, which is equal to my hypotenuse squared, the sum of those sides squared. All right, so x squared plus y squared is equal to r squared. You see how it's still derived from that triangle. So now let's do the last and the fourth one. And so this is my angle. This is my what side? Opposite. This is my adjacent. So what deals with opposite and adjacent? Tangent. And so tangent theta is equal to y over x. All right. And so when we're dealing with these conversions, those are the four equations that we're going to be using. Okay, so let's kind of play around with the first examples. All right, so we're going to convert the following points from polar pairs to rectangular pairs. So a polar pair is represented by r comma theta, and a rectangular coordinate is represented by x comma y. And so I need to go from r thetas to xy. Make sense? Cool. So here's my first polar pair. And now I need to get to x and I need to get to y. Well, what does x equal? R cosine theta. All right. And y equals what? R sine theta. And so what is my r? 2. And so x is equal to 2 times cosine of my theta, which is pi. And so what is cosine of pi? -1. So -1 times 2 is what? -2. So my x value is -2. See how we did that? Cool. Let's keep going. And so now my y is equal to r sine. And so now my r is 2. And then times the sine of pi. And so what is the sine of pi? 0. And so 0 times 2 is still what? 0. And so my polar pair is 2 comma pi. And so my rectangular pair is -2 comma 0. Now, I want to show you that this should make a whole lot of sense when we sketch this thing out. So 2 comma pi. So where is pi located? Left. It's my x-axis and it's left, exactly. And how far did I move left? 2. And so I went out 2. Now, doesn't that make sense to match up with our rectangular coordinates? There we go. All right, so let's look at part B now. So now I have 4 comma 5 pi over 3. And so how do I get to x? X is equal to what? R cosine theta. So now I'd have what? 4 times cosine of 5 pi over 3. And again, just like before, how did I want you to think of cosine? Cosine deals with what? X. So doesn't that make sense that we're using cosine with x? All right, so now I have 4 cosine of 5 pi over 3. So what is the cosine of 5 pi over 3? Positive 1/2, exactly. And so now I have 4 times 1/2, which is 2. And so my x is equal to 2. And now I need to get to my y. And so y is equal to what? R sine theta. And so now I'd have 4 times sine of 5 pi over 3. All right. So what is the sine of 5 pi over 3?
Square root 2 over 2.
Negative square root 3 over 2. All right. And so now what happens with my 4 and 2? 4 divided by 2 is 2. And so then I tack on my negative. So now I have a negative 2 square root 3. And so now my ordered pair is 2 comma negative 2 square root 3. All right, let's do it again. And so now if I go from my polar pair, and I need to get to my rectangular coordinate. All right, and so now what is x again? R cosine. So now I have negative 3 cosine of 7 pi over 6. And so what is the cosine of 7 pi over 6? Negative square root 3 over 2. And so what is my x? What happens to my negatives? They cancel, so now I'm left with 3 square root 3 over 2. And so now let's do the y. And so my y would be what? R sine theta. So now I have negative 3 times the sine of 7 pi over 6. And so what is the sine of 7 pi over 6? Negative 1/2. So now I have negative 3 times negative 1/2, which is what? I'm going to call it 3/2. All right. And so, yes, 1.5 is the same, but I'm going to go with fractions. And so now we have 3 square root 3 over 2, comma, 3/2. Now, I want to show you what that is actually doing. All right. So if I have 3 square root 3 over 2, comma, 3/2, what quadrant is that actually in? My x is positive, my y is positive, so what quadrant am I in? I'm in my first quadrant. And so I'm not going to show exactly where it is, but it's in the first quadrant, yes? And so on this one, where is 7 pi over 6, though? That's in the what quadrant? It's in the third quadrant. It's right here, isn't it? But why is it in the first quadrant now? Because my radius is what? Negative. That's what flipped it over there. All right? I just wanted to show you how that worked. All right, so let's look at example 5 now. And so on example 5, we're going to convert from rectangular, which is the x comma y, and now I'm going to go into polar coordinates of r comma theta. All right? So now I have x comma y. Now I need to get to r's and thetas. So what are we going to use to get to r's and thetas? Okay, I'm going to get to my theta with my tangent thing, but I want to get my r first. So what are we going to use? Pythag. All right, and so we're going to use this one right up there. And so now we have negative 2 squared plus 2 squared is equal to r squared. So what is negative 2 quantity squared? 4 plus 4. So how much is that? 8. And then what do I want to do with it? I want to square root it. So r is equal to the square root of 8. So on this one, we have square root 8. Now, I'm not exactly sure, but we might need to look for our perfects. So when we simplify our radicals, who's perfect in 8? 2's not perfect. 4. And so the square root of 4 is 2. And so this could simplify to 2, and then square root who's left? 2. All right. I'm personally okay with square root 8. However, we might have to simplify on this exam. All right. And so there we go. And so now I got my r. Now I need to get to theta. And so now which one do I use to get to theta? My tangent theta is equal to the y over the x. And so what's my y? 2 over my x of negative 2. So what is 2 over negative 2? Negative 1. So when is tangent negative 1? At 3 pi over 4. When else? And at 7 pi over 4. And so now it's like, which one is it? You just pick one. Just kidding, you don't. All right, and so this is where this little tip comes into play. All right, I would highly recommend you sketch out where this little thing is. So if I have negative 2, 2, which quadrant am I in? I'm in the second quadrant. So that tells me what angle measure I actually want. Okay, so which angle measure do I actually want? The 3 pi over 4. All right, I would highly recommend you just plot the little point. Now, from here on out, I'm going to do that first, okay? But I wanted to prove a point on this one. Prove a point, that's funny. All right, and so what is my r comma theta? 2 square root 2 comma 3 pi over 4. All right, so negative 2, 2 is the same as the polar pair of that. All right, let's do it again. And so now if I have my rectangular pair as 1 comma negative square root 3, let's get to our polar pair. So we need to get to r. And so what are we going to use? Pythag. So now I have 1 squared plus negative square root 3 squared is equal to r squared. Now, I didn't plot it. I should have. What quadrant am I in? I'm in quadrant what? 4, okay? That's all I'm going to do, and that's going to tell me kind of how to set this up. All right, and so now I'd have 1 squared plus negative square root 3 squared, so what was that going to be? 1 plus 3. 1 plus 3. So 1 plus 3 is what? 4, and then what do I do to it? Square root it, so r is equal to 2. Awesome. And so now I need to use my tangent theta. So tangent theta is equal to what? What is my y? Negative square root 3 over 1. All right. Now, what really happened is I got like a negative square root 3 over 2 over 1/2. All right. And so when is tangent negative square root 3 over 2 over 1/2? At 2 pi over 3 and what else? And at 5 pi over 3. And so now you just pick whichever one you want. Which one do you pick? 5 pi over 3. Why do we pick the 5 pi over 3 one? Because it's in the 4th quadrant. All right. And so now my polar pair is 2 comma 5 pi over 3. All right, let's do one more, maybe 2. All right, so now I got 0 comma negative 5. Okay, so on this one, let's figure out where it is. I'm going to do this without even doing any work. So where is 0, negative 5 at? It's an axis. Where is it? Which way did it go? It went down, and so it just went down right there. And so what is my r? How far did it go down? It went down 5. And what angle measure did it go down at? 3 pi over 2. And so when it's an axis, you really don't even have to do any work if you truly understand how polars work. All right, and I want to prove a point to it. So let's do another one. And so I'm going to say it's like negative 6 comma 0. All right, so if I have negative 6 comma 0, where is that at? It just went left. It's an axis. It just went left. And so what would be my r? 6. What would be my angle? At pi. All right, because it just went left. So it's at pi.